So we've come to the end of our series on foundations, and I thought I would take a moment and just kind of recap everything, maybe dive a little bit deeper into some pictures, some actual code, and also kind of give you a view into some of the guides that I provide on buildingcodetips.com. Kind of diving a little bit more into the code requirements, spend a little bit more time on some of those construction tips, and try to help keep you moving. If you've been following along, hopefully the tips through all these videos have helped you out on your DIY projects, and you're able to smoothly move into the next section or phase of your project. But if you haven't, hopefully here, this video right here will kind of answer some of those questions that are left out there and keep you moving. So let's dive into the whole thing. Foundations, right? We've talked about in the beginning of all these series, we've talked about frost depth, we've talked about footing size, rebar, UFR grounds, we've talked about foundation walls, heights, drainage. We've just kind of touched on all those little components, waterproofing, damp proofing. And so today I'm going to kind of run you through a bunch of pictures and some code. I've kind of picked out some different codes to kind of show you where I'm pulling some of this information from, and then again, hopefully keep you moving. So thanks for following along if you've worked through this series with me, and let's jump into it. So I'm going to hop over to some pictures right away here, and I'm going to start off with just talking about excavation and footings, right? That's the most important component of your project, even though it may not be the prettiest part. Starting with a solid foundation on solid ground, not on fill, and working your way up out of the ground, your project just begins smoother. You have a nice flat wall, flat footings, everybody's happy. So okay, so I pulled up 3 different pictures here, and there's kind of 3 different things to talk about in each of them, just to again keep your mind working on your project so that you're able to get it done correctly. So here we've got just a standard footing, right? They've come in here, they put 2 rows of number 4 rebar. That is pretty typical from everything I've known and everything I've seen. 2 rows of number 4, which is 1/2 inch rebar, is pretty typical in a footing. Now, if you read through the code book, and if there's no amendments in the specific state that you're in, then you technically don't even have to have rebar if it's a low wall, right? Or even in footings, if you read through the code, there's nothing in there that specifically says you have to have rebar in your footing. Now, it's highly recommended. And even in like a low wall, which would be 48 inches and lower for your stem wall, for your foundation wall, technically you don't have to have rebar. Now again, your jurisdiction where you live, you get your permit, you ask your building inspector, hey, do I need rebar? They might tell you, yeah, we want you to put some rebar in. You're definitely going to want to do what they're looking for. But reading through the generic code book, the IRC, it's not necessarily required. But here you can see they've just used 1x material. In my previous videos, I talked about trying to use material that would that you could reuse, right? Because you're probably not a foundation person by trade, and so you don't want to buy 1x6 material and not be able to reuse it. So 2x6, 2x8. You can go in and then use that as backing. You can use it as truss bracing. You can use it, as long as it's good when you pull it off. You can use it for studs or whatever you need. But buy something that you can reuse. Pull those forms off when you're done, and use them. So this is just kind of a standard footing layout, right? They went in here, they dug below frost line. Frost line is huge. I live in a cold weather state, and so you have to be below that frost line. And when we're talking about minimum requirements as you get into maybe warm weather states, code book says 12 inches. Now, does that mean that that's what you got to do where you're at? I couldn't tell you, but that's what the code book says, and I'll actually show you that reference here in a few. So we're 2 feet below grade where we're at, so we can see here's our grade, and we're going to be 2 feet below that, which they've got, and they've got clean soils. So there's no fill that's visible as an inspector when I show up on the site. You know, I'm looking to see if I see any fill or bricks, debris, something like that. And if I do, then that's fill. Now it could have been there for 100 years, but it's still fill, right? It's been put in there. It's got debris in it. You could have some weird settling or something like that. And so it's got to come out. And in this picture right here is an example of that. So you can see right here, they've gone in and they had found a little bit of debris of some sort. I don't know what it was that they found. But they've gone in and they just kind of over excavated this small area a little bit. And what they did is they just went and poured it through. So they just let their concrete kind of mushroom out underneath those forms. And then when they pour this in, they try to get that footing as flat as possible. Now here, I wanted to show you this picture specifically for the idea of frost coverage. And we talked about being, you know, minimum 12 inches if that's what your code is requiring, if you're in a warm weather state, or whatever your frost depth is. Ours is 2 feet. And you can see here they've went and this particular project is a house is going to get moved and set on top of it. But they're not 2 feet below grade. You can see right here the top of this footing form is almost level with top of grade. So right in this area here, this has got to go, you know, 2 feet deep to meet code requirements in our area. And so there was a correction call on this, and so they went in and they actually dug these footings down so that they could then just go in and put a little stem wall or foundation wall on top of it and meet those requirements. Okay, so then now that I've kind of talked a little bit more about, okay, get your frost depth, right? No fill. If you have to dig the fill out, it's okay to pour your footing deeper in those sections. But here's just kind of the code requirement as it's stated in the IRC. This exterior footing shall be placed no less than 12 inches below the undisturbed ground surface, as I'm reading it kind of here at the top. And then it says, where applicable, the depth of footing shall conform to 403, so it's in 403.141 and 403.142, which here talks about frost protection. So again, it's 12 inches minimum, but then obviously if you're in colder states, you got to be below that frost line. So it's except where otherwise protected from frost, foundation walls, piers, and other permanent supports or buildings or structures shall be protected from frost by one or more of the following methods. So you can go below the frost line, and then here, you know, if you're on solid rock, or there are some other options available as far as construction purposes go. Maybe some foam insulation can be placed down along the exterior side of the foundation or even horizontally. In our area, we don't really dive into any of those. Most people just dig it down below the frost level. So that covers like the basics on foundation footings, right, and excavation. So then let's talk a little bit about foundation walls, okay? So foundation walls become the simpler part of a foundation. All right, you've gotten through the excavation part of it, you got through the fill, you got your footings in, you got them as flat as possible, hopefully. You got any rebar in there that you're thinking about putting in, and then vertical rebar, right? If you're putting vertical rebar in, if you have a high wall, which would be 4 feet or higher, then you're required to put in vertical rebar and horizontal rebar in that wall. But if it's a low wall, at least per the IRC, you don't necessarily have to put anything in. Now, I would recommend it, highly recommend it, at least some verticals and maybe one horizontal in the wall, tying the footing and the foundation wall together. But let's take a little peek at some of those pictures as well. Okay, so here's some pictures on foundation walls, and this is kind of the forming of it. Now, when you're doing this again with your own materials, you might end up getting like 3/4 inch plywood, or maybe you think 5/8 plywood is going to suffice. Again, get something that you can reuse, or even look into renting forms. I know in our area we can rent forms, and they'll do the square footage takeoffs, and they'll figure out how many panels you need and load them up on a trailer and take them to your site. You can set them all up. They'll give you all the clips and brackets and all the things that you need. You use it, take them down, take them back, and you don't ever have to worry about it again, which is a great option for someone that's maybe doing this themselves. So if you're building yourself a new house or an addition or something like that, you're not going to want to go buy actual concrete forms, but you want to do the process on your own, save yourself some funds. that's a couple options. You know, use materials you can reuse or try to rent the forms. Here we have just you can see right here they're in the process of putting forms in. You can see they've got all of their bar in here. The vertical rebar in most instances, at least in our area for residential, is wet set, which what they mean by that is they've poured the footing, it's still wet, and they've taken their vertical rebar pins, which are these guys here, these vertical pins, usually number 4, and they've just stabbed it into the top of the footing when it's still wet. So there's no like hook bar like you'll see on a lot of commercial jobs. Most of it's just wet set in there. It dries. The next day you go back and you start putting your horizontal rebar in. So pretty simple as far as rebar install goes. Again, if you get above that 4 feet, you're going to get into some technical stuff on how much rebar, how big it is, how close it is together. And that's something you're probably going to want to get with your building department on, so that you make sure you have the correct sizes before you get into it too far. In a nutshell though, that's pretty simple as far as foundation walls. Here you can see a picture. They've got, these are 2-foot panels, so they got a 4-foot wall here. They've got their rebar in here, even though, like I said, below 4 feet. You could argue that it's not required, but recommended. Here it looks like they may be in the process of putting another panel on. Maybe this is a 3-foot wall, and I think this is the same picture right here, just different sides with the forms put in. Now we've got everything poured, right? It's all been poured, and now we've got to protect it from with insulation. If you've got like a slab on grade, you've got waterproofing, damp proofing. If you've got a basement, crawl spaces, you got to make sure you get your vents in there. And so here's a few more pictures that I thought I'd run by with you as far as the different types of foundations and what to think about depending on which one you're going to do. Here, this would be a slab on grade. And so they've gone in here, and it's typical process to go in and insulate the inside of your foundation wall on a slab on grade. So this is a slab on grade. It'll eventually get backfilled, and then the slab will pour up right here over the top of it. Your inspector might tell you they want you to carry this all the way up to the top and maybe cut it at an angle for energy savings. I know in our area sometimes we're required to ask contractors to do that. In this particular instance, they're allowed to carry it right below the top of the slab that's going to get poured in here. And this is like an R10 2-inch foam board insulation, and they just cut it and place it in there before they backfill. So that'd be kind of the main component. Think about if you're doing a slab on grade. Now, here's another idea of same thing. So this is a wall that sits above grade, right? And so it's not necessarily needed to be insulated like this one is over here. You can see right here they've insulated this wall because it's going to become part of slab on grade. But right here, the slab will continue across, and this now becomes basement wall. So it's not necessary to insulate it in that fashion. Waterproofing or damp proofing. Basements, you know, if you're doing any type of basement, it is huge to make sure that you have waterproofed the outside or the exterior of your foundation wall. The last thing you want is moisture weeping in through pores in the foundation wall and creating mold or huge moisture problems on the inside of your house. And especially if you went and framed it in, you've drywalled it, and now you've got moisture trapped in there. There are multiple different options when it comes to waterproofing or damp proofing. Damp proofing is required for any basement if there's a living space on the other side of it, which would be any basement. But if you get into like high water table issues, a lot of moisture, they're going to swap that over to waterproofing. The difference is just simply that waterproofing is completely sealing it. But I think you'd want to do that anyways, regardless of what your water table is. I don't think you'd ever want to take the chance of not completely sealing it off. Code requirements is that it goes from the top of the footing to whatever your grade level is. And so grade requirements are your grade has to be at least 6 inches below top of wall from earth to wood, because your sill plate is going to be at that 6-inch mark, top of wall. So you're going to go down 6 inches, and that is going to be probably the minimum for your waterproofing. It depends on what you're backfilling. If you have 2 feet sticking out of the ground, well then you don't have to waterproof that. It's just wherever your grade level is down to top of footing. So you can see what they've done here. They've gone along and they've waterproofed all of this with like a roll-on tar material. And I'll actually show you the code requirement for that and kind of show you some of the list of items that can be used. Crawl spaces are really common in our area. It's probably, in my opinion, one of the most popular options when it comes to building an addition or a house or something, just simply because you can get underneath of it, right? You get your crawl space in, you can get under there if you need to add something, take something out. You just have access to it. Obviously, it's going to come down to probably cost. Is it cheaper to do a slab or is it cheaper to do a floor system? Floors are a little more bouncier, but they're warmer. Concrete's cold. So, I guess you kind of pick which direction you want to go there. But there's 2 different types of crawl spaces. There's a vented crawl space and a conditioned crawl space. In our area, we don't really allow conditioned crawl spaces. Just simply for the idea of the moisture problem, right? Moisture getting into that crawl space and not having it way out. You dive into more mechanical requirements, having to put a fan down there, you're conditioning it, so then you're paying to heat it in a sense if you've got some type of heat duct down there, and then you're also going to have to exhaust it. It just probably creates more problems than what it's worth, but if you've got items down in there that you want to keep heated, well, then it might make sense. But for a vented crawl space, it's just kind of open. It's vented, right? So it's open to the elements. You go in and you install these vents that you can see here. I've got a couple pictures up of these vents, and the vents are required to be installed. I did not bring up the code requirement on this, but I believe it's like 1 square foot per 150 square foot of crawl space. I could be wrong on that a little bit, but when you go to do your numbers, you might work off something like that. And then when you submit it to your city for your permit, they'll tell you if you're off by 1 or 2 of them. But the basis is are you doing a vented, or are you doing a conditioned crawl space? And just understanding that there are different requirements for that. Vented crawl space is obviously much easier and less intensive than a conditioned crawl space. One item that I did not touch too in depth on is monopore. So you can monopore, which means that you can pour the footing and the wall together, or you could even pour the footing, the wall, and the slab together. And that's what these pictures are. This is a monopore for, I believe, a garage. And so they've gone in here, and our requirements are for a monopore is that they only have to be 12 inches below grade in an unconditioned garage under 1,000 square feet. I know that's a mouthful, but that's only for our specific area. So like wherever you go, there might be some different requirements with monopores, but for an unconditioned garage, so there's no heat in it, it's under 1,000 square feet, they don't require you to go down to frost level. They only tell you, well, you need to be 12 inches below grade, kind of like standard code requires, and so you're getting through all that topsoil and getting down to some actual native, and then you can monopore it like you see here. So they've gone in here, they've put their bar in, and you can see they've already snapped their line. So they'll come in here and pour this all in one shot, and they'll wet set their anchor bolts in where they need them, and then they should be able to get started framing. So that's another option out there, depending on what it is that you're pouring. A monopore can be a great way to just get through the excavation and concrete phase of your project, get up out of the ground with one pour. It can be especially cost effective if you have to use a pump, because you can just do it one time. If you got to pour a footing and then a wall and then a slab, that could be 3 pumps, and that could be really, really expensive. So if you're able to do it all at one time, take advantage of it. So another component to think about is anchor bolts. Anchor bolts I touched in some of the previous videos. I talked a little bit about the requirements for anchor bolts. And then it's really not the end of the world if you miss 1 or 2 of them, because you can go back and put some wedge anchors or maybe some Titan bolts or something in there. But at the end of the day, you want to try to get them as close as possible, because you don't want to have to go back, and you don't want your whole entire building set with wedge anchors. You'd like to have actual anchor bolts that are set down into the concrete that are holding it up. And so minimum requirements: 10-inch anchor bolt, 1/2-inch diameter, and 7-inch embed. So meaning 3 inches of it is sticking up out of the concrete. which allows you to put down your sill plate and have room for your nut in your washer. Where are they located? General code calls for within 12 inches of the plate breaks and 6 inches on center otherwise. And so you can see right here, and just in this picture, you know, you're going to have a break here in the corner. So your sill plate, every time it breaks, meaning you got a new board, you had to cut it for some reason, there's a break in that bottom plate, you're going to have to put anchor bolts on either side of it. So if there's a break right here, you've got one within 12 inches, and then you definitely have one within 12 inches here. You're going to have the same thing turn in the corner, and then 6 inches on, or 6 feet on center thereafter. So when you're deciding what your lumber package is, if you're going to do 14 foot or 16 foot or 10 foot treated bottom plates, then you know what your layout's going to be. So it's important to think about that as you start to dive into getting materials and which direction you're going to go for those lengths on your sill plates. I have a couple pictures here. I was out on site doing an inspection, and this is a perfect example of not getting your foundation below the frost line. This was an existing house, and this is the footing. This right here on this picture is the bottom of the footing. So it's literally just kind of sitting on top of grade, or the grade over the years has eroded and it has exposed it. And then if you pop over to this picture, you can see how the ground is froze and the foundation is heaved or cracked. And so this whole section of foundation, there's a crack here, this is a huge crack. And so they've had to go in and they had to clean this up. They've had to provide as much backfill as they could for protection. They've had to fill the cracks. They've had to jackhammer things up and make them level. And, well, it just created a whole bunch of unwanted work. So if you're out there and you're working on a project, you know, biggest thing is get on native soils and get below your frost line. So before we wrap up, I told you I'd go over a couple sections of code. And again, this will kind of show you a sneak peek into what my guides offer. They dive a little bit more in depth into the code, some of the tips, and spend some time, a little more in-depth time on just kind of each component of the construction process for you DIYers out there. But I wanted to show you the code requirement on waterproofing / damp proofing. And then I also got some details kind of straight out of the code book, out of the IRC. They kind of show you the different methods of foundations that you can do depending on where you're at and what works for the project you're working on. And so let's look at the damp proofing one, and then we'll finish this video up and get you out there and get you moving. So this is the code requirement on foundations for damp proofing and waterproofing. So you can see it's R, so that stands for the IRC 406.1. So it's talking about concrete and masonry foundation damp proofing. So damp proofing, again, I kind of mentioned earlier, is the requirement for a foundation where there's a living space on the other side, which would be a basement. But then once you get into something where you might have a high water table, you're going to drop down into this little section right here where it talks about waterproofing. So what I really wanted to touch base on was just the different methods that you can use to meet that requirement. So here for waterproofing, they're talking about all these different types of methods. So you can use on a hot mopped Phelps, you can use roll roofing, that's 55 pound, polyvinyl chloride, polyethylene. So there's all these different types of chemicals or products that you can apply to that foundation to make sure that it is waterproofed. Granted, I don't know if I think I would want my foundation waterproof no matter what. So I would probably stick to some of these options here. And I'm sure nowadays there are even a lot more options than that. So you can reach out to your building inspector, your building department, if you have something specific that you'd like to use, and they may be able to lead you down the right road. But this right here is just the general breakdown on damp proofing and waterproofing. So now let's hop over to some of these different details. And so here's the monopore slab that I just showed you here a second ago, where you kind of monopore the footing, the wall, and the slab all at once. This is like an interior thickened slab footing. Here you've got a CMU block wall. We don't usually see a lot of CMU where we're at, but where you're at, maybe that is common, and it is totally fine to use CMU block. You just need to make sure that you get it grouted properly and the rebar in it properly per the code requirements in your specific area. Here's kind of your standard footing and stem wall foundation system. And then here, you know, they've just gone in and poured the whole thing. So you're the width of the footing, and then you're the height that you need to be for your wall. And it's just one big, huge mono-poured stem footing, which that works as well too. It's going to cost you a little bit more in concrete, but it might save you in labor for setting forms or rebar or whatever it is that you have going on. Here's a few more, kind of talks a little bit about some of the rebar, showing rebar in here. Here you're showing hook bars, and I talked a little bit about that earlier, how, you know, in our area, most people just wet set those vertical rebars. Here they're showing for CMU block an actual hook bar that is set in the footing and poured within the footing. Maybe that's a requirement where you're at, and you might want to just check and see if that is. I know that CMU block kicks in some more requirements as far as rebar is concerned, so just make sure you follow whatever your minimum code requirements are in that area. So this has been with Building Code Tips. You know, if you made it through this video, you know, congrats. If you're working through your project and this has helped you out, that's awesome. If you hop over to buildingcodetips.com, I've got a free kind of before you get started checklist. And that just kind of walks you through things to think about as you work through permitting and you think about design and structural components and what your inspector might ask for. Just things to kind of keep the brain moving and keep your project moving for you. And I'll also put the link to that freebie in the comments and in the description below, so you can just click on it and go over and snag that thing, and hopefully it'll just kind of provide you with some of those little things you might not think about, and that could be hiccups or costly down the road.